So hey guys, this is Dipesh, and in this particular video we'll be talking about another type of machine learning problem called as classification problem, and more specifically we'll be looking into logistic regression. Okay, so now as we in our first lecture I told you that there are basically three types of machine learning. First is supervised machine learning, second is unsupervised machine learning, and the third is reinforcement learning. So basically, in supervised machine learning, there are basically two types of problems that we can solve. The first is classification, and the second is regression. Now we already saw in our fourth lecture that what regression problem is, and we also looked into linear regression, which is a model that we can use to solve regression problems. Okay, so now in this fifth lecture we'll be looking into classification problem, and we'll also see how we can solve classification problem using logistic regression. Okay, so just a quick note before we begin, that implementing these algorithms is very easy, but understanding them is a bit challenging. Now I try to repeat this as many times as possible in the videos, because it is very important that as a beginner you don't waste your time implementing or understanding the this algorithm from the scratch. Okay, just try to get a high level overview of how the algorithm works, and how it try to solve the problem. Okay, so let's get started. So now, what is a classification problem? Now, classification problem is a problem or a task of identifying which set of categories or class does a particular sample or an object belong to. So, what this definition means is that we have an object. Okay, so let me just draw here. So we have this object. Okay, and what we want to do is we want to identify which class this particular object belongs to. Now this object can be anything. Okay, this object can also be an image. So for example, if we have an image, and let's say we want to classify if the image is of a dog or a cat. Now here we are basically assigning a class to a particular image. Okay, we are basically identifying if a class if the image is of a dog or a cat. So this is basically an example of a classification problem. Okay, another example would be your spam detector. So when you're using your email app or your Gmail app, there is a spam detector that comes with your application. Now what spam detector does is basically, for example, let's say this is your spam, this is your mail. Okay, now what spam detector does is it basically identify if the mail is a spam, or if the mail is a ham basically. Okay, so if the mail is a spam, then it basically predicts that the mail basically belongs to the spam class. Okay, so spam class. And if the mail is not a spam, then it basically assigns a class of no spam to the mail. Okay, so in simple words, it just identifies a particular class that the mail belongs to. Okay, so this type of problem, we call this type of problem as a classification problem, because we are basically trying to identify which class does a particular object belongs to. Okay, now that object can be anything. Okay, that object can be an image, or that object can just be a sample from a data set. Okay, so now one of the major difference between the regression and classification is the target variable. So in classification, so basically in regression, what we are trying to do is we are trying to predict a continuous variable. So in this on my screen you can see that the in regression problem we had this three independent variables, and we were trying to predict the salary. Okay, salary is basically a continuous variable here. Now in the regression problem we are trying to predict a continuous variable, whereas in classification problem the target variable is a categorical variable. Okay, categorical variable means it consists of classes. Okay, so for example, this is basically a test data set of diabetes test of 4 patients. Okay, so each row each row basically represents one person. Okay, each row basically represents data about one person, and it also shows the result of the diabetes test. Okay, so the outcome column basically represents if the person has the diabetes or not. Okay, so each sample basically each sample consists of three main data points. First is the age. Okay, the second one is the glucose in the body, and the third is the body mass index, that is BMI. And the classification problem here would be that what we'll do is we will use these three independent variables. We'll try to use age, we'll try to use glucose and BMI. We'll try to use this information to predict the outcome, basically predict the class that this particular sample belongs to. So the problem would be something like that. So given a person's age, glucose and BMI, we want to predict if the person has a diabetes or not. Now this is basically an example of a classification problem. Okay, and also remember that here the outcome column, which is the variable that we are trying to predict, is a categorical variable. Here we have two classes. One is yes and the other one is no. Okay. Okay. Now moving forward, there are basically two types of classification problems. One is binary classification, and another one is multi-class classification. Now binary classification basically means there are two classes. Okay, in total we have two classes. So one example that I gave you earlier was the spam detector. Okay, so in spam detector, as the mail comes, the spam detector either assigns the label of spam. It basically either identifies the mail as spam or not spam. Okay, so here we have only two classes. Okay, one is mail, one is spam, and another one is not spam. So this type of problem is called as binary classification, because we have only two classes here, and we are trying to predict one class out of two. Another one is multi-class classification. So unlike binary classification where we have only two classes, in multi-class classification we can have more than two classes. So for example the iris dataset. Okay, if we look at the iris dataset, we have three species here. Okay, three species of flowers here, and we want to identify which given some data about these flowers, given data about any one flower, we want to identify which which species of flower does this sample belong to. So in front of me you will see that here we have basically four independent variables. Okay, we have four independent variables. We have sepal length, sepal width, we have petal width, petal length, and petal width. Okay, and we want to predict out of these three classes which particular class does this sample belong to. Okay, so now here we have three main classes. One is iris certosa, other one is iris versicolor, and iris virginica, and we want to predict which flower, which particular species is this flower. So here the total classes is 3. So that's why this is basically an example of a multi-class classification problem. Okay, we are trying to predict more than two classes. Okay, now some of the most common common and most popular machine learning models for classification problems are logistic regression, k nearest neighbor, decision trees. Basically all of these are the some of the most common and widely used machine learning models. In this particular video we'll be looking into logistic regression. Okay, logistic regression is basically the most simplest and the most fundamental classification model. All right, in our further videos we'll be talking about we'll be talking about other algorithms like KNN, decision trees, support vector machines, etc. Okay, all right, so let's get started with logistic regression. So now what is logistic regression? So logistic regression is basically a method or a machine learning model which is used to solve classification problems. Okay, by default, okay, by default it solves only binary classification. So basically, if we wanted to let's say predict if a mail is spam or not, now in this particular case we have only two classes, so we can use logistic regression here. Okay, so logistic regression does not support multi-class classification, it only supports binary classification. Okay, so how does logistic regression work? First of all, don't get confused with its name. Okay, because just because it has regression in its name. Okay, logistic regression basically is an extension of linear regression. Okay, and it's very similar to linear regression. That's why it's named as logistic regression. But don't get confused just because it has a regression in its name. It has nothing to do with the regression problem. Okay, we use logistic regression only for a classification problem, more specifically for a binary classification problem. All right. So now basically in linear regression, what we are trying to do is we were trying to we are trying to find the most optimal line here. In linear regression, we our main goal was to find the most optimal line of best fit that will basically summarize this data set. So in this data set we just drew this line from the center of this from the center of the scatter plot, just because it it summarizes the entire data set, and basically it predicts the continuous variable in the most optimal manner. Okay, so in linear regression our only goal was to basically find this line of best fit. Okay, but in logistic regression our goal is to basically find a line that will separate this data set into two parts. Okay, so for example, if this is basically, uh, let's say from this diabetes data set, we we basically drew a scatter plot of glucose against BMI. Okay, so if we drew a scatter plot of glucose against BMI, and let's assume we get a scatter plot of something like that, like this. Okay, so now if we were doing linear regression, then what we would have done is we would have tried to predict a line, or basically find the most optimal line that will basically summarize the data set. So basically we would have tried to find a line that goes through the center of this data set, something like that. Okay, but in logistic regression our main goal is to basically find a data set, find a line that will separate this data set in two parts. Okay, because what we are trying to do here is we want to basically classify some samples as some samples belonging to a particular class, and so the rest of the samples to belonging to another class. Okay, basically what we want here is we want to draw a threshold line. Okay, we want to draw a threshold line that will basically that will classify the data in the most optimal manner. Okay, so that this is basically the most fundamental thing about logistic regression. Okay, so once we train our logistic regression, then afterwards what it will do is basically it will draw a particular line of separation. Okay, let me draw another line properly and show you what exactly we are doing here. So what will happen is, what logistic regression tries to do is it basically tries to draw a line of separation here. So basically what will happen here is, once this line of separation is drawn, once the model basically trains and finds the best line that separates our entire data set into two parts, what it will do is it will basically decide a threshold boundary. Okay, so once this line is decided, what will happen is all the values below this line, okay, all the values below this line will belong to a particular category, and all the values belonging above this line will belong to another category. All right, So for example, let me also change the color of the data points here. Okay, so as you can see, basically what logistic regression does is it basically tries to find the most optimal line that will separate this data set in the most optimal manner. Okay, so once this optimal line is basically found out, what it does is it basically sets a threshold boundary here. Okay, and what it says is whatever values that belong to this that belong below this line will basically belong to one particular class, and another value, and all the values, all the data that belongs above this line will belong to a particular class. Okay, so for example, here we are trying to predict if a person has diabetes or not. Okay, and we drew a scatter plot of glucose and BMI. So what will happen is all the people below this line. Okay, let me also draw this. All the people below this line, okay, they will basically have diabetes. Okay, have diabetes. Whereas all the people mm, all the people above this line, okay, I think I just made a mistake here. All the people belonging below this line will not have diabetes. Okay, not have diabetes. Whereas all the people belonging above this threshold will have diabetes. Okay, so basically again let me repeat this again. What what logistic regression does is it does not find a line of best fit. It basically finds a line that separates our data set into two different classes. Okay, and it basically sets a threshold boundary. Now what basically logistic regression does is basically we give this we give the model our data, and the model basically using this boundary that the model has basically found out. It basically gives the output, basically gives the probability of that particular object belonging to that particular class. Okay, so basically let's say what let's say that we have trained the logistic regression model. Okay, and it has found this line, and it has successfully separated our data into two classes. Okay, and also it has successfully decided a particular threshold value here. Okay, now what will happen here is if we give a particular data. Okay, for example, if we give the logistic regression this data. Okay, if we give a logistic regression model this data, and if we if we tell the model to predict the outcome, then the prediction will be a probability value. Okay, here if we gave the data about the patient to the logistic regression model, the logistic regression model basically will output a probability value. Now this probability value will decide this probability value is basically the probability of the sample basically belonging to a particular class. So here, since we are trying to predict if a person is having diabetes or not, what this probability will represent is what this value will represent is the probability of a person having diabetes. Okay, So let me repeat this again. So what we did was we had this data. Okay, we had this data about diabetes, about the diabetes test, and we trained our logistic regression model. And what that model did was basically it found out a line of best separation. Okay, it separated our data into two parts. Okay, and what it did was by deciding a line of best separation, basically what it did was it said that it says that whatever value that belongs to this below this value, below this line, whatever data point or whatever sample that belongs below this line will belong to a particular class, which is diabetes or not diabetes. Basically, if any data point that belongs below this line, then that particular patient will basically not have diabetes. And if the sample point, or if the patient's values belong above this line, then that person will have diabetes. Okay, and how does this model decides? Basically, it is upon us. Okay, basically what this model will do is it will take the data. Okay, and it will basically output a probability value. Okay, it will basically output a probability value of if the person has a diabetes or not. Okay, now it is up to us to decide its threshold. Okay, now the logistic regression model basically decided a threshold line here. Okay, it decided it trained, and after training it decided a best threshold line that separates this data set into two parts. Okay, into two classes. Now it is upon us to basically decide the threshold. Okay, the model will basically only output a the probability value. Okay, now it is upon us to decide if that patient has the diabetes or not. So for example, what we can say is, if the probability value, we can say is that if the we can say that the if the probability is greater than 0.5, can say that if the probability is greater than 0.5, then the person is having diabetes. Okay, if the if the values below, if the probability value is below 0.5, then we can conclude that the person do not have diabetes. Okay, so it is upon us to basically decide the deciding threshold. Okay, the model will only output a probability value. Okay, it is upon us to basically decide if the person actually has diabetes or not. It is upon us to basically decide the deciding threshold, basically the threshold, and the most common threshold is 0.5, which represents 50%. So if the values if the model thinks that basically if the model outputs a probability of more than 50%, then the person has a diabetes. Now we can also change this to any number. We can say that if the value is below 80%, or below above 90%, or something like that, the deciding value is upon us. Okay, it is we have to basically decide we have to decide a threshold first. Okay, and then we can basically decide if the person has a diabetes or not. The model will only output a probability value here. Okay, now how does the model basically assigns the probability here? Now, as I said that what logistic regression does is it basically trains and finds the most optimal line of separation here. So this line of separation is at the core basically found out using something called a sigmoid function. Okay, something called a sigmoid function. So sigmoid function is basically at the core of logistic regression. This function is the this function basically decides the probability. Okay, this is basically the this function is basically used to output the value of the model. Okay, so what this function does is basically it's the sigmoid function is a special type of function. So whatever value you give, it will convert that value in the range of 0 and 1. Okay, it doesn't matter what value it is, even if you give it 1 million, or let's say minus 500, or 105. Okay, if any real value, it basically it takes any real value and it converts that value, basically it converts that value into a range of 0 and 1. Okay, now higher values, if you give any higher values, it will it will output higher probabilities, and if you give any lower values, it will output lower probability. So the sigmoid function is basically at the heart of logistic regression. So if you look at the curve, if you look at the curve of this function, then the curve of this function will look something like this, something like an S. Okay, its range is basically between 0 and 1, which is the same range for as probability. Okay, so whenever we want to basically output probabilities in any machine learning algorithm or any machine learning model, we mostly use sigmoid function. Okay, now don't worry if you don't understood this what the sigmoid function is or how it will be used. Just remember that the only thing that logistic regression does is basically finds the most optimal line of separation. Okay, and what it does is it basically gives us a probability value for each sample. All right, so now once you have understood what logistic regression is, how it works, now let's look at the cost function in classifications. So now we knew that in our regression problems, we saw that the cost function, we saw what cost function is, and how we uh, how we use cost function to calculate the parameters of our model. Okay, so now for regression problems, we have the most common loss function was mean squared error, but for classification problem, the most common cost function is called as cross entropy. Okay, this is this is specifically made for classification problems. Okay, so now again, like cross entropy is basically a loss function that we use in classification problems. Now there are two types of now even this cost function has two main versions. Since we have two types of classification problems, that is binary classification and multi-class classification, the cost function, that is cross entropy, also has two versions. One is binary cross entropy, which will be used for binary classification problems, and the other one is categorical cross entropy. Now categorical cross entropy is used for multi-class classification. Okay, so let me repeat this again. The most common cost function or loss function that we use for classification problems is called as cross entropy, and there are basically two versions of this loss function, as since we have two types of classifications. Okay, one is binary cross entropy, which is used for binary classification problem, and the other one is categorical cross entropy, which is used for multi-class classification problems. All right, now here I have highlighted the formula for binary cross entropy. Okay, it's a very simple formula. T here basically represents the true value, and the P basically represents the predictive value. Okay, so true value is the actual value of your sample, and the predictive value basically is the output that the probability that your model has predicted. Okay, so for example, here for our diabetes dataset, we know that the age, glucose, and BMI column are our independent variable, and the output column is a target variable. So the output column or the outcome column will consist of this outcome column is our true column, because it consists of the actual values of the samples. Okay. Now this is basically a binary problem. Therefore we have 1 and 0 here, where 1 basically represents yes and 0 represents no. Okay. So the outcome column contains the true values, and the predicted value, and the predicted column basically represents the probabilities that the model has predicted. So if I gave the model this data, if I gave the model data about a person's age, glucose and BMI, then the model will basically represent basically output a probability. Okay. So these are all the probabilities that the model has predicted. So so this is the, so let me basically show you how we calculate binary cross entropy. Okay. So the binary cross entropy formula is basically the summation of various things. Okay. Now, in order to simplify this formula further, what I have did is I have created this condition here. So, if the target value, okay, if the true value, basically, if the true value is 0, then we will use this formula. Whereas, if the true value is 1, then we will use this formula, that is minus log of p. Again, like by true value we mean this ones and zeros. Okay, this true value basically means the outcome column. Okay, so basically let's continue. Let me show you how we can actually compute the binary cross entropy. So now for example, now here our for the first sample our true outcome is 1, and a predicted probability is 0.6. So here we have a condition that if the true value is 1, then we will use minus log of p. Okay, where p basically represents a predicted value, which is 0.6 for the first sample. So what we'll do is we'll find the minus log of 0.6, which is again 0.22. Okay, and we'll do the same thing for the second sample. Now for the second sample, our true value is 0. Now here as according to a condition, if the true value is 0, then we'll use minus log of 1 minus p. Now here what we'll do is minus log of 1 minus p, and now p is 0.2. So what we'll do is we'll find minus log of 1 minus 0.2, which will give us 0.009. Okay. And again for the third sample, the true outcome is 1. So what we'll do is we'll use according to this condition, we'll find out minus log of p, and our p is 0.5. So we'll find out minus log of 0.5. So again the outcome will be 0.3. And if we do the same thing for the fourth sample, the value that we get is 0.6. Okay. Now once we do this for all our samples, all we have to do is just add them up. Okay. All we have to do is just add them up, and the answer that we get is 1.2, 1.2.1, 1.21. Okay, so this is basically our loss. Okay, this is basically our loss. Now this loss is still pretty good because it's close to 0. In our regression problems, the main goal was we want the loss to be as close to 0 as possible. So we have the same scenario here. Even in classification problem, we want our loss to be as close to 0 as possible. Now 1.21 is still very good because it's still not that far from 0, but then again The reason we got this the loss this low is because our probability is pretty close to the accurate values, you know. So for the first sample, you can see that our predicted value is 0.6 and our true value is 1. And even for the second sample, our true value is 0, but our predicted value is 0.2, which is still close to the true value. Okay, so our predicted values are not that bad. That's why we got such low loss value. But in real world scenario, this loss would be very high. Okay, this loss would be very high. Okay, so this is an overview about how logistic regression works, and what basically a classification problem looks like in general. Okay, so let me repeat this again. Okay, so basically a classification problem is a problem where we try to identify the class of a particular object. Okay, now this object can be anything. This object can be either image, or it can also be a sample from a big data set. Okay, now in classification there are basically two types of problems. One is binary classification, and the other one is multi-class classification. In binary classification we have two classes, and in multi-class classification we have more than two classes. And the most common and the most basic ML model that we can use to predict that we can use to solve classification problem is called as logistic regression. Now logistic regression only supports binary classification, so we use logistic regression only when we only for binary classification problems. So for example, if you want to predict if a mail is spam or not, then in that case we can use logistic regression. Okay, now unlike linear regression, okay, where we try to find a line of best fit, we in logistic regression we try to find a line of best separation. So in logistic regression we train our model to find a threshold separation line. Okay, so once this line is found out, basically what logistic regression does is it separates our data set into two parts, and it says that if any data point falls below this line, then that data point will not contain diabetes. In case of our diabetes example, that basically sample or data point will not have diabetes. Whereas if the data point resides above this line, then that data point will have diabetes. Okay, so this line is basically a threshold, like a separation line. Now if we give what logistic regression does is it outputs a probability value. Whenever you give logistic regression some data and you try to predict the class using logistic regression, the logistic regression will basically output a probability value between the probability value between 0 and 1. Okay, now this probability value can be anything, 0.1, 0.2, 0.9, anything, but it is upon us to basically make the decision. Okay, we have to set the deciding decision threshold here. So what we can do is we can say that if the model outputs a probability higher than 0.5, okay, if the model outputs a probability of 0.5, then we can say that the model we can say that the person has a diabetes. Okay, in context for the for our diabetes data set. Okay, we can say that the sample or data or the data point belongs to the particular class. Now it's not necessary that the decision boundary be just 0.5. It can be anything according to your plan, according to your problem that you are trying to solve. Okay, and at its core the logistic regression uses sigmoid function. Sigmoid function is basically a special function which converts numbers into the range of 0 and 1. Okay, then again the cost function for most of the classification problem is binary cross entropy and categorical cross entropy. Okay, binary cross entropy is used for binary classification problem, and categorical cross entropy is used for multi-class classification problem. Okay, so yeah, this was an overview. In our next lecture, what I will do is I will try to implement logistic regression using Python. Okay.